Okay, section 6.1, vectors. What is a vector? Well, a vector is just something that represents a value that has a magnitude or size. And what makes this different than just a number, which could have a magnitude, or a scalar, something to scale, it also has a direction. Now typically, or in vectors, the direction is an angle. Okay, so that's all the vector does, is represent that. Okay, we got a couple of different ways to describe how we describe the magnitude, size, or the vector itself. Well, first of all, let's take a look at where we get a vector from. So let's start with the point K being at, let's say, 1, 4, and B is at the point 4, 7. And we want to find what it's called the component form of the vector KB. Now, notice that arrow was not a regular arrow, it was just the top half, because we don't want it to look like the ray from geometry. We just want it to make it describe something. So, just a rough sketch. Here's the point 2, 3, 4. K, that's point K here. So 2, 3, 4. Let me clean that up. And here's 7, 4, 7 is right here. So that vector, starting here, ending here. So when we're looking at a vector, we do have, because of the direction, we have an initial point, and a terminal or ending point. Now, to find the component form, what we're looking for is, okay, how far and in what direction does X change, the horizontal, and how far does the Y, the vertical, change? Well, to do that, we just go ahead and find the change in X and the change in Y. Well, since we want to make sure we go the correct direction, it's terminal minus initial. So the X coordinate from B minus the X coordinate from K. So 4 minus 1, and then do the same thing for the Y. Y coordinate minus Y coordinate. So from the terminal minus initial. Now, to separate this from, so 3, 3. Now, to separate this from a ordered pair, making it look like this, or an interval, we use these triangular type brackets. That tells us it's a vector. So this vector goes 3 units to the right and 3 units up. So that would be the vector when we move the initial point to the origin. And we do that a lot. And that's what we envision this as. We have 3 horizontal in the positive direction, 3 in the vertical direction, positive vertical direction. Okay? So, let's look at this and find the component form. Well, why don't we find the magnitude of that then too? How long is that? Well, looking at this vector, this visual representation, this picture for that vector, notice we just created, it's not necessarily to scale, of course, a nice right triangle. So the magnitude of vector KB is just the square root of 3 squared plus 3 squared, 2 squared to 3. Got that backwards. Here's 3 squared to 2. That's better. Square root of 18. Yeah, this almost looks like the absolute value, but it has a double line. And that's all this. In other words, it's the hypotenuse. And here are the 2 legs of a right triangle. How about the direction? Well, the direction is with respect to the positive x-axis, unless it deals with north and south. Then we know we go back to that arrangement. But this one, if it just says, okay, what is it? Our typical normal angle. So we have the 2 legs. So the tangent of the theta, the angle, there, is the y over the x. Oh, we know that one. That goes without saying. And what can we use? Radians or degrees? Well, most of the time it's degrees. Sometimes radian slips in by what the instructions say. Okay. But all component form is telling you is describe the vector in terms of the horizontal and vertical components. How far left to right? How far up and down does it go? Let's do the same 3 things for the vector with the initial ray at, how about t is 1, -2, and we go to point R, which is 4, -5. We don't have to draw it. We can if we wanted to, but we don't need to. Actually, we may end up doing that in component form. So let's first find the component form. So component form, and we want vector RT. So R to T, initial, terminal. So 4 and 1, but which order? Terminal minus initial. Then do the same thing for the y, terminal minus initial. I did it again. 3. Oops, -3. Now, not the same vector. We got the same magnitude. It's not quite the same direction because this direction is going, oops, wrong place, wrong direction, this direction. So it's really thinking of, okay, what is the angle from the positive? So what is that theta? Well, we know the reference angle is 45, so that direction is 135. So we got to go back into thinking about the 2 different quadrants. Sometimes we let the direction go around into quadrant 3 and quadrant 4. Sometimes we just do a positive and a negative. Most of the time our theta our direction is always in between one revolution positive and one revolution negative. We don't like going around and around for vectors. Okay? So let's start off with a different look to it. Let's start off with a vector. That has component form of 2, -3. Let's get a representation of that. When it's quote this, it's not. I don't think it's called standard position, but we sort of say this is how we think about it. So start off with a initial point at the origin. Go 2 to the right, 3 down. That would be the vector. Okay, so got a couple different things we can do with this. We also have things called unit vectors. Well, one thing we take with unit vectors is to take the vector itself and okay, what is the component form of the vector if its length, if its magnitude in the same direction is 1? Well, how do we resize this down to 1? How do we go from a magnitude, by the way, what is the magnitude of that vector? Just do the Pythagorean theorem. Again, no worries about negatives because that just tells you direction, so square root of 13. Now for the unit vector in the same direction, we just take the component form of the vector and resize it by dividing by the magnitude. And simplifying, of course. Okay, there's one other kind of thing we do with what are called unit vectors, and that's another description for this. Instead of this left and right, because some applications fit better, we could use what are called the standard unit vectors. Basically, there's two different vectors. There's vector I. By the way, sometimes we won't put like the names like this down if we don't give a specific point. If we're given a vector by the name, just a letter, it's just a letter, sometimes in bold print or script. That vector is 1 unit to the right, no vertical. And vector J, no right, 1 up. And we use what's called a linear combination of that. So for this here, for the 1 up here, I'm going to really enlarge this. So here's the vector we have. We're trying to fit it into a linear combination, in other words, through addition or subtraction of that vector I and this vector that goes up, J. Well, how do we take this vector here and enlarge it to get to here? How do we go from 1 and enlarge it, scale it, to 2? Well, we multiply by 2. So 2 times I. Now, how do we go from J going, instead of going up 1 unit, go 3 units long, times 3, but we want it in the opposite direction. So that's all that is. It's looking like taking the components that way. So work on, try the practice that's sitting there. That was on the board and that's next to it, and we'll see what go from there. Alrighty.